Assalamualaikum everyone. I am Pritam. Here we will demonstrate our open-ended project, which is a analysis of 5-bus load system. We are group 1 and our group members are flashed on the display. Here. So our task is to perform the load flow analysis on the given circuit. So it is a 5-bus load system given here, and the bus data and transfer line are also given here. As per task 1, we have to perform the load flow of the power system and identify the slack bus, also the bus voltage and the power of each bus, and also find the line flow and the losses of the system. For that, we will use Etap for simulation. In Etap software, we will create 5 buses here, here, and here, and we will connect them with an impedance like this. We inputted the nominal bus voltage from the data table. For bus 1, it is 10.6, and for other buses, it is 10 kilovolt. As the base kV is 10 and base MV is 100. For each bus, we will create a load and generator. For bus 1, it is swing bus, as shown here. It is the swing bus for generator 1. And for bus 2, we will use a load and generator given here. And for bus 3, 4, and 5, we will use a lump load as a loading. Okay. We have inserted the impedance as per the table. Here we inputted the percentage value of R, X, and Y, which is resistance, impedance, resistance, and reactance, and the line charging given here. And we select the percentage and the base MVA. After all the value inserted, we will run the load flow. After the load flow analysis, we can see that the bus 1 voltage is unchanged. So we can say that the bus 1 is the slack bus, and the bus 3, 4, and 2 are over voltage, as we can see here. We can also see the load flow in every bus and every line here, and we can also see the voltage drop and the power loss in every line here. For task 2, we have to write in MATLAB code adapting any load flow analysis method to verify the obtained result in task 1. So we have written this MATLAB code here, and first of all, this is the line data. We have written as a matrix here, and we calculated the Y bus with this. Then we added the bus data with generation and load. With the help of Gauss-Seidel method, we calculated the bus magnitude and the bus angle, bus voltage magnitude and bus voltage angle here. And this is the tolerance here, this is very low. So our magnitude is this, and this is our angle in the result. So it's almost similar with the Etap simulation software. We can say it is almost accurate. This, and this. So after that, we have to calculate the load flow from buses, between buses. So for that, we have to calculate the admittance between the buses, and with this line, we have to calculate the admittance between the buses and find the current flowing between them, and thus we can find the apparent power between them. And this is our result shown here, the power flow between buses. We have also calculated the schedule power here, this formula, and it is almost similar with the simulation. And this is our schedule power, this and this. And it is also accurate with the simulation. Thank you.
Question number 3, we have to make an under voltage event in bus 4 below 85%. In Etap simulation, we have to first simulate this. Here we can see in bus 4, the voltage is 102.3%. We have to make it under voltage. So increasing the load, we can do that. In nameplate, we have to increase the power to 150. Now simulate this again. Here you can see that the voltage is 84.56, which is under voltage. And now we have to overcome this. To overcome this, we have to connect a capacitor in bus 4. And in rating, the MVR bank will be 113.9. And simulate this again. Here we can see that the voltage is now 102.3%, which can overcome the under voltage problem, For
task 4, we have been assigned to determine asymmetrical fault in line 1 to 3. That is for bus 1 and bus 3. Firstly, we set both the lines as fault. The red line resembles that they have been short-circuited. Then we click on the 3-phase fault analysis. We will determine line to line, line to ground, and double line to ground voltage, ground fault. This is the line to ground fault voltage for bus 1, fault current for bus 1, and as well as for bus 3. This is the line to line fault voltage and current for bus 1, and this is the line to line fault voltage and current for bus 3. And for the double line to ground, this is the fault voltage and fault current for bus 1 as well as for bus 3.